Hi, it's Mrs. Moret with help for the Algebra 2 Review for Final, Unit 2, Part 1, Polynomials. So this first section, simplify each expression, write your answer in standard form. So standard form means that when we're finished, the polynomial will be separated just by terms rather than multiplication. And the power of the variable will be written in descending order. So the highest power of the variable would come first, and then all the way down to the constant, or the term with the lowest power of the variable. So to get started on number 4, I wrote it out a little bit already, but we eventually have to multiply all 3 of these factors together. So the 4, the x plus 2, and the x minus 9. So I would first multiply x plus 2 by the 4, and that gives us 4x plus 8. And now we're going to multiply the 4x plus 8 by the x minus 9. So I do like to use a factor box to multiply because it just does a nice job of keeping the terms organized and easy to read. And so I'll line the top of the box with 4x plus 8 and the side with x minus 9. And then inside the box is the product. So x times 4x, negative 9 times 4x, and then x times 8, and negative 9 times 8, which is negative 72. So we've got all of this multiplied together, and when I look inside the factor box, I notice there are some like terms here. And so when I write this out in standard form, the highest power of x comes first, 4x squared. And then I'm going to add those together. Negative 36x plus 8x is negative, so minus 28x, and then minus 72. And that's the answer. On number 5, there's actually 3 factors to multiply together because this here is being squared. And so it's really tempting to just say, oh, it's x squared plus 25. But it's actually not, because it really means x plus 5 times x plus 5 times 2x minus 7. And so if you just squared the x and the 5, you'd miss out on a whole term that would go in the middle. So same strategy as before. We can multiply these two together and then multiply the answer by 2x minus 7. All right, so x plus 5 times x plus 5. I'll make a box for that. And that gives us x squared, 5x, 5x, and 25. And we have these like terms in the middle. So that x plus 5 squared is equal to x squared plus 10x plus 25. And now we're going to multiply this by the 2x minus 7. And so I can make a box again, only this time the box has to be like a 3 by 2 so that we have enough room for all of our terms. So I'll do 2 in that direction and 3 in this direction. And that'll work. So 2x minus 7, x squared, 10x, and 25. And then just put all the products inside. So this will be 2x to the third, negative 7x squared, and 20x squared, negative 70x, 50x, and negative 175. Okay, and again, I want to think about the like terms. So here they are, the x squareds. I can add those together. And same with 50x and negative 70x. I have two sets of like terms. So my final answer here, the 2x to the third comes first. And then that's going to be a total of 13x squared, so plus 13x squared. And this will be minus 20x, and then minus 175. Okay, on number 6, so kind of have a couple things going on. We have the 2 out in the front, so I'm going to multiply that by x minus 6, and I'm also going to find x plus 3 squared, and then multiply those two answers together. All right, so 2x minus 6, if I distribute the 2, I get 2x minus 12. And we're going to multiply that by the answer to x plus 3 squared. So I'll figure that out here. I'm using a factor box. Okay, so I have all the products there, and I notice that's going to add up to 6x. So this gets multiplied by x squared plus 6x plus 9. Okay, and so to do that, I'm going to make another factor box that's 2 by 3, just like we did on number 5. So 2x minus 12, so negative 12, and then x squared, 6x, and 9. All right, so now we'll just multiply. So we have 2x to the third, negative 12x squared, 12x squared. Oh, that's interesting. And then negative 72x, 18x, and negative 108. Negative 12 times 9, negative 108. Okay. All right, so again, some like terms here. These two actually add up to 0. This should have been, I didn't put this squared on that. It should have been squared because x squared. And then these two are like terms, and they add up to negative 54. So we have 2x to the third, that's 0, and then these add up to negative 54x, so minus 54x, and then minus 108. And that's finished. And then the last one here, number 7, we're going to follow the same strategy. Multiply 5x by x minus 1, multiply x minus 3 by x plus 2, and then multiply their answers together. So we can just distribute, that's 5x squared minus 5x. And now I'll make another factor box for x minus 3 times x plus 2. X squared, 2x, negative 3x, and negative 6. So those will add up to negative 1 or negative 1x or just negative x. So this will be x squared minus x minus 6. Okay, and now we multiply this together. So we need one more 2 by 3 factor box to do that. So 5x squared negative 5x, x squared, minus x, minus 6. Okay, so this will be 5x to the 4th, negative 5x to the 3rd, also negative 5x to the 3rd, and then positive 5x squared, negative 30x squared, and 30x. All right, so those will add up to negative 10x to the 3rd. These will add up to negative 25x squared. So we'll start with our 5x to the 4th, the highest power, and then minus 10x to the 3rd, and that's minus 25x squared, and finally plus 30x. Okay, so the other part of the polynomials unit had to do with key features on a polynomial graph. And so that's what we have here for the second part. Determine the following for the polynomial graph. So what are the roots? So the roots are the places where the function crosses or touches the x-axis. So this polynomial has 3 roots, x equals negative 3, and then 0, and then 4. So x equals negative 3, x equals 0, and x equals 4. Are there any double roots? Yes, this is a double root here because it bounces rather than passing through. So yes, at x equals 4. Okay, next question, is the polynomial odd or even? And then is its leading term positive or negative? So we learned about how you put those two ideas together to figure out the end behavior. So when I look at this, I know how to answer those two questions. But in general, I'm going to make a little kind of table down here. If a polynomial is, let's see, we'll do it like this. I need to split it into, because there's kind of 4 possibilities when it comes to end behavior. So if a polynomial is an even degree, its end behavior, meaning like what's happening on the left end and the right end, its end behavior is the same on both sides. So it can be even and positive or even and negative. Both of them, they're the same on both ends. Only if it's even and positive, it ends going up in the positive direction, and even negative in the negative direction. So you can probably see our answer is even and positive because these ends match these ends. All right, so even and positive. But to go over the other 2 possibilities, could be odd and positive or odd and negative. And if it's odd, then the ends are opposite each other. And then it's going to be the right side that will go in this direction. So what I mean by that is an odd polynomial with positive leading term. On the right end, it'll be going in the positive direction, and the negative on the left, and then opposite for odd negative. On the right side, it'll be headed in the negative direction, and then in the positive direction on the left side. All right, So again, this one matches what we see here, so it's even and positive. And then finally, between which two roots is there a relative minimum? So between the roots, there are these relative minimum and maximum points. You can see this one is a relative minimum because it's at the bottom. Whereas this one is a relative maximum. And so a relative minimum is going to be between the roots, but on the negative side of the x-axis. And a relative maximum would also be between the roots, but on the positive side of the x-axis. So the relative minimum for this graph is right here, and it's between x equals -3 and x equals 0. Those are the roots the relative minimum lies between. So between x equals -3, and x equals 0. All right, so that is the end of the review for Unit 2, Part 1.